All right, this is the continuation of the review we started in class. So this is to assist you to prepare for the test, for a quiz, what have you. And so I just wanted to, now that I have a bit more time, I'm not so restricted, I wanted to go back to F, right? For F, down here, but I'm going to just read it. According to those models, if the sticker prices were reduced to $3 per roll, what's the revenue? You need price and revenue, right? And you don't have that. You have rolls and revenue up here. So this equation is comparing rolls and profit. So basically what I did, because they're giving me the price per roll and they're asking what is the revenue that you're expecting. Well, you don't know how many rolls you're selling at that point. I mean, you could, I guess, keep going down, right? Reducing this to 325 till you get there, like you keep doing this chart, but it's just too tedious, right? So I just quickly put price into L1, profit stays the same. This is your equation. And for F, that would, right, if the price is 3, the profit is 78, okay? You could find how many rolls you'd be selling, right? You just go 78 divided by 3 and you'd find out how many rolls that would be. And G is asking, I relabeled it G, by the way, right? Like you just make sure you do that when you get your paper copy. G is Y2 is equal to 38 because that's the profit, right? If you have a revenue of 38, how many rolls would you expect to sell? Then you got to go back to the original. So basically change your L1 back to the number of rolls, perform a regression, and do this. But because this is finite, like this doesn't keep on going, you could probably just type it into Y1 as is, and then come up, and then just do this quickly instead of performing the regression, just type it in. Like this equation is easy to type in, okay? And then H, what price will result in the company breaking even? I'm talking again price. So I'm using this equation here, which compares price and profit, right? I'm using that equation. I find my x-intercept, and it's right, it's at the point at the, like it's over here where you break even. Yes, you can charge 0, but then you'll make nothing, so we almost omit this one. But it's that one that you're interested in. And so that's 6.25 right here. Okay, so that's where I get that. So at this price, you'd be breaking even. You would be making money, you wouldn't lose money. It's at the break-even point, okay? I, domain and range, I didn't specify, but I would say that that is the domain and range. Again, on a test, I won't go back and forth. So if you stuck with these values where it's 0 to 50, that's fine. So up to 50 rolls. And your profit should be the same either way. It's this one that would change based on if are you talking price or are you talking rolls, right? So I would give you both. So if it's the price, you'd go 0 to 6.25, right? And so we're gonna keep that and then graph it. Let's go ahead and graph this, and I'm assuming again that this is rolls. It's unit, right? It's per unit of, this will be profit or revenue in dollars. 0, 0. I need to account for 50, 10, 20, 30, 40, 50. Just happens to work out perfectly. I need to account for our revenue of 78, so 20, 40, 60, 80, that's good. And so my vertex is at 25, 78, 13. That'd be 70, that'd be 70, 75, 78 is closer to here. And I want to land right here. Okay, so and again, that's why if you write down the equation, you will be correct, right? Because you are depicting the right equation here. And that's what it is. So that's that for this question. Let's move on to number 3. So this is type 0. Okay, points given, right? So you type this into L1, that's our X. We type this into L2, that's our Y. And determine the quadratic equation. So we're going to do that. Stat calc 5. So we're going to go ahead and do that. Clear everything. I'm doing this real time. How about that? All right, so 5, 35, 65, 95. Oh. So mistakes and all. 37.074. Not that it matters putting in the 0 there. So take your time so you don't make a mistake. So I'll quickly check. And yeah, it tends to round, but if you go over it, right, it actually displays the actual value typed in. Okay, so we're good. I'm going to perform the regression. So there it is. Okay. Negative 0.079 x squared plus 7.923x minus 0.91. Okay. So that's our equation. And we just basically followed that, right? We followed the points that they're giving us, okay? Determine the vertex of the parabola and explain what it means. So we're gonna find it. We turn on plot 1 now, because if you haven't already. And we're gonna go zoom 9. Perfect. Window, I'm just gonna go, there's already negative, and here negative 5. There it is. Second trace. Second trace 4. That's 50.17 and 197.84. Okay, that's what I get. And what does it mean, right? That at a distance of 50.17 meters, right, comma, the rocket reaches the maximum altitude, of 197.84 meters. Okay, that's what that means, right? So you're basically stating the obvious, right? It could be the time at which it reaches a maximum height of 197.84, but in this case it's distance and height. So, right, the distance at a distance of, or at a horizontal distance, if you want to put it that way, that's what it is. Okay, so that's explaining it. So C, if Mr. D sets up 90 meters away from surrounding buildings slash structures, would it be considered safe? So I'll give you a picture here, right? If this is the launch site here, right? If we don't know where it's gonna land, right? Is the building here or is it there? That's the question. Like, are we in the danger zone or are the buildings further away? So the only way of finding out is you have to find the x-intercept. Okay? So we're gonna go y2 is equal to 0, second, trace 5. So we're gonna go ahead and do that. And that's 100.230. So we know that the building, right? The building is right here, right? This is at 9, like Mr. Dirksen is 90 meters away. Mr. D is 90 meters away, right? So this is 90 meters from a building. But according to this model, this will land at 100.23 meters away from where the launch site is, okay? So in this case, we would have to say it's not safe, okay? It is not safe, as you need more than 100.23 meters of clearance. That's C. It's not safe. So you've done some calculations and you're showing me that there. D, how much further would you have to move in order to have enough clearance? So we basically just go 100.23 minus 90, so that's 10.23 meters further. That is to be like exactly on the nose, right? Or more. At least 10.23 meters, okay? So that's C, D already. E, determine domain and range. And we're talking distance, right? So we know that our domain is 0 to 100.23. And our range is, sorry, our range is also 0 because it does hit the ground. Okay? It does hit the ground. And so our maximum height is 197.84. Okay, so there it is. And F, if Mr. D thinks that the rocket can best be seen at a height of at least 65 meters, what distance will the rocket be seen best? So F, right? So think about it this way. It's launched. And so this is the 65 line. So we're going to have to find this distance and then this distance, subtract, sorry, my bad, right? This is the path, this is the line of 65. So between this distance and this distance, right, the difference is where we're going to see it best, okay? So we do that, y2 is equal to 65. There it is, so second, trace 5, I'm going to find the first one. That's 9.154339. And then it happens again. Over on the other side, 91.9, 91.189642. Right, it happens twice. So delta distance is 91.18 dot 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 minus 9.15 dot 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 delta D going to be, so it's 82.04 meters, and I used all decimals. It's not that bad. It's a little bit more work, but it's doable, right? So here, graph the scenario distance in meters, right? Height in meters. And I need to account for 100.23 here. So 25, 50, 75, 100, 125. The maximum height is 197. So 50, 100, 150, 200, 250 just to be safe. Okay, so there it is. It's 100.23, so almost there, right? So just don't have it right on 100. And this is 50.17, 190 something, it's right there. And notice that this isn't quite at 0, 0. I don't know if you caught that, right? Very important. So we are at 0.91. So not quite. So it's, I guess, a little bit on a structure. And there it is. Okay. So 0 and 0.91. Oh, sorry. It is actually, it's negative, right? It's negative. So what we're going to do here is I'm going to have to adjust my points a little bit. When I did it originally, I had 5 decimals everywhere, and it worked out to be 0, 0. But when this happens, it's still modeling the trajectory, but because I removed 2 decimals for each of them, it changed it a little bit. So the original parabola, like, it starts a little bit down here and then cuts through here, right? So what happens is you actually have another x-intercept here, because we wouldn't consider the negative down here. We wouldn't do that. So what we're going to do is quickly, if you graph it and you find that other y-intercept, the x-intercept, we're going to find the one that's closer to the origin. 0.11, so 0.12, right? So we're going to do that here. 0.12, 0. But, and this happens sometimes, okay? It happens sometimes. The way around this, okay, is if you use the actual values here. If you would have used these actual values, you wouldn't have had to worry about it. But if you follow the equation, you kind of have to follow. But I can guarantee you that you'll never have a negative and 0.91 there. Like, you won't have a negative initial height. It might be positive, at which point it would have been easy to just place here. But I can guarantee you that it won't be, so you don't have to worry about that. Okay, so that threw you off, then I apologize. So we're going to continue now with the last one. Right, last one. A hunter spots a deer from the top of a 35-yard cliff. He draws his bow. My bad. His bow. Change that. Points up, and before releasing his arrow, estimates that the arrow will reach a maximum height of 80 yards after 1.75 seconds. The arrow is expected to hit the deer, which is 1 yard above ground. Okay, it's important there. Determine the quadratic equation, modeling the flight path of the arrow. Okay, show all work here. So for A, we're going to have to do significant amount of work. So if this is a story, right, of something that's happening, right? So this is 35 off the ground, and the arrow is pointed up, and it's going to hit the deer, right, Yeah, don't look at my skills here, okay? When it comes to drawing, not really good. Anyways, so it hits the deer, which we know is 3 yards above ground, okay? So it's gonna hit it. Obviously later it's gonna fall down, but it just, that's the end of the story. Sorry, 1 yard, 1 yard. So boom, hits it and stays there. So um, how are we gonna do this? Okay, so we know that this is time and this is height. You need 3 points. Okay, we're told that it will reach a maximum height after 1.75 seconds of 80 yards. Okay, so starting point, vertex, get out horizontally and say, well, if it, I know I'm coming back to 35 yards, right? Because it's pointing up, coming back. So it would be 2 times, right? 2 times that will give me this. So that's 350. Okay. So 350, 35. And you might ask, like, what about this 1 yard thing? This doesn't really help you because you don't know the start, you know it's gonna go down to 1 yard, but that's about it. And so your 3 points here would be X and Y, right? You have 0, 1.75, and then 350. You start at 35 yards, you reach maximum of 80, and you're back to 35. Those are your 3 points here. So this is L1, L2, stat, calc, 5, and our equation there comes up to be negative 14.694 x squared plus 51.429x plus 35. So this is A. This is the work that accompanies A. Okay. B, determine the domain and range in this situation. So for domain, we go from time 0 to time here, right? So we need to figure out when are we going to be 1 yard above ground, because that's when the action ends. Okay, so we're going to go, so in this case it's not the x-intercept, y2 is not 0 but 1, second trace 5. So we're going to go ahead and do that. Give me 1 second. So you go ahead and do that, and it seems like it's on the x-axis, but it's really just above it. If you were to zoom in, you would see that. So we're just going to go ahead and find that. So it's 4.07. Okay, so that's when the action ends. That's when the time stops. Okay, so range in this case would be, so time goes from time 0 to when it hits, and my range, the lowest it gets is 1 and the highest it gets is 80. So watch this, right? In this case it doesn't hit the ground, so you have to be careful there. C, how long does the arrow stay at or above 75 yards? So then it's just 75 here, right? You graph it. So y2 is equal to 75, second trace 5. And there are 2 instances, so I'm going to just write down those 2 numbers, okay? I'm going to do the first one. So it's 1.1667, right? Second trace 5 for the other one. You can't see it on your screen, but I trust that you will do that yourself, right? You will do this yourself. So delta time. So we're going to go ahead and do that. Remember, at least 4 decimals. And that's 0.67 seconds. okay? And then D, how long does it stay at or above 25 yards? So we're changing that to 25. We graph it, and this is going to be interesting, right? So it's back here already over, but we ignore all of this. So it's really just from time 0 till it gets to it for the first time in real life, right? Because time is positive, right? Second trace 5, and it's 3.68. That's it. You don't have to find this point up here, because really the first instant, like, you start at 0, so it's right until that point, so no need to subtract. So we'll go y2 is equal to 25, second trace 5, and you get 3.68 seconds. That's it. Okay. E, graph the scenario. So we'll do time in seconds, height in yards. Okay, so what do I need here? I need to account for 4.07. So 1, 2, 3, 4, right? You give yourself enough room. The maximum height is 80. So 20, 40, 60, 80. So 1.75 gets you to 80 up here. 0.35 will be right there. And then this, you got to be careful, right? 4.07, 1 yard. So you're just there. So it's 4.071, 1.75, 80. This is 0.35. And if you want to, you can say this is 3.5, 80. Y is equal to negative 14.69x squared plus 51.43x plus 35. And you're done. Okay, that concludes this review. Hopefully it helps. See you tomorrow.